Welcome to our channel. Jupiter is the solar system's biggest planet and the fifth planet from the Sun. It is a gas giant with a mass slightly less than 1,000th that of the Sun, but more than 2.5 times that of all the other planets in the solar system combined. Here is an insight on the news. Astronomers discover strange hexagon on Jupiter. Number 8. A little bit about Jupiter before we get on about what happened. After the Moon and Venus, Jupiter is the third brightest natural object in the Earth's night sky. It was named after the Roman deity Jupiter, the ruler of the gods, and has been seen since ancient times. Although Jupiter is mostly made up of hydrogen, helium accounts for 1/4 of its mass and 1/10 of its volume. Jupiter, like the other major planets, is thought to have a rocky core with heavy components, although it lacks a well-defined solid surface. The heat generated by its internal contraction is larger than the heat absorbed from the Sun. The planet's form is an oblate spheroid, with a minor but perceptible bulge near the equator due to its fast spin. At various latitudes, the outer atmosphere is divided into many bands, with turbulence and storms along their interacting borders. The Great Red Spot, a massive storm that has been seen by telescopes since at least the 17th century, is one of the most visible results of this. Number 7. To put the size of what's happening in context. Jupiter is surrounded by a robust magnetosphere and a weak planetary ring system. Jupiter's magnetic tail is over 800 kilometers long, 5.3 AU, 500 million miles, and spans almost the entire distance between Jupiter and Saturn's orbit. Io, Europa, Ganymede, and Callisto, the 4 massive Galilean moons discovered by Galileo Galilei in 1610, are among Jupiter's 80 known moons. Io and Europa are similar in size to Earth's moon. Callisto is smaller in size to Mercury, while Ganymede is bigger. Number 6. Something strange happened on Jupiter. After a death-defying maneuver, a NASA spacecraft discovers a massive new storm on Jupiter. San Francisco, California. Last month, NASA's Juno mission detected a massive new storm whirling near Jupiter's south pole, only weeks after performing a stunning death-defying maneuver. On November 3rd, during its most recent close flyby of Jupiter, Juno saw the newest maelstrom, which is approximately the size of Texas. The storm joins a group of 6 other cyclones in Jupiter's south polar region that Juno has seen on earlier Jupiter flybys. By the way, the interactions revealed 9 cyclones around Jupiter's north pole. The southern storms are arranged in a very consistent pattern. 5 of them had previously created a pentagon around a center storm that was the size of the entire United States. That girdling structure is now a hexagon as a result of the additional storm. Number 5. What did the scientists have to say? These cyclones are new weather phenomena that have not been seen or predicted before, said Chung Lee, a Juno scientist at the University of California, Berkeley, in a statement released December 12. He went on to say, "Nature is revealing new physics regarding fluid motions and how giant planet atmospheres work." Juno circles Jupiter every 53 Earth days on a very elliptical course, collecting the most of its data while it is closest to the giant planet. And those encounters are really close. The probe skimmed a scant 2,175 miles, 3,500 kilometers over Jupiter's cloud tops during the November 3 approach, the 22nd research flyby of Juno's $1.1 billion mission, NASA officials said. Juno, on the other hand, needed some clever flying to get it through the ordeal. Juno's track would carry it under Jupiter's shadow for 12 hours on November 3, according to the mission team, and the solar power probe would have most likely died as a result. "We would have gotten cold, really cold, during a news briefing here yesterday at the annual autumn meeting of the American Geophysical Union, AGU, where the scientists reported the new findings," Juno project scientist Steve Levin of NASA's Jet Propulsion Laboratory, JPL, in Pasadena, California, remarked. Number 4. What did the strange geometric shape look like? Even for a gas giant planet draped in multicolored bands with a red spot bigger than the Earth, there's a startling sight near Jupiter's south pole. A group of spinning storms structured in an exceptionally geometric shape may be seen near the planet's south pole, mainly hidden from prying eyes of humans. Scientists have been baffled by the storms since they were first discovered by NASA's Juno space mission in 2019. On Earth, the storms are similar to hurricanes. Hurricanes on Earth, on the other hand, do not congregate at the poles and spin around one another in the form of pentagon or hexagons, as Jupiter's strange storms do. Now, a team of researchers led by Andy Ingersoll, a professor of planetary science at Caltech, has figured out why Jupiter's storms behave so differently. They accomplished it using maths drawn from a proof made approximately 150 years ago by Lord Kelvin, a British mathematical scientist and engineer. Jupiter's storms, according to Juno crew member Ingersoll, are strikingly comparable to those that batter the east coast of the United States every summer and autumn, but on a far bigger scale. If you went below the cloud tops, you would probably find liquid water, raindrops, hail, and snow, he adds. The winds would be hurricane-force winds. Hurricanes on Earth are a good analog of the individual vortices within these arrangements we see on Jupiter. But there is nothing so stunningly beautiful here. Number 3. How do these things happen? Jupiter's storms, like those on Earth, tend to develop around the equator and then migrate toward the poles. Hurricanes and typhoons, on the other hand, evaporate before they get too far from the equator. The planets of Jupiter just keep traveling till they reach the poles. The difference is that on the Earth, hurricanes run out of warm water and they run into continents, Ingersoll explains, says Jupiter. This hypothesis, however, does not explain the behavior of the storms after they reach Jupiter's south pole, which is peculiar, even when compared to other gas giants, according to Ingersoll. Instead of a geometrically ordered group of storms, Saturn, a gas giant, has one massive storm at each of its poles. Number 2. These phenomena struck a chord with the scientists. The solution to why Jupiter has these geometric patterns, while other planets don't, according to Ingersoll and his colleagues, may be found in the past, notably in work done in 1878 by American scientist Alfred Mayer and Lord Kelvin. Mayer had been floating circular magnets in a body of water and discovered that they would spontaneously organize themselves into geometric designs like those found on Jupiter, with forms that varied depending on the amount of magnets. Kelvin developed a mathematical model to describe the magnet's behavior based on Mayer's findings. People were thinking about how spinning particles of fluid might organize themselves into polygons back in the 19th century, Ingersoll adds. Although these fluid polygons had been studied extensively in a lab, no one had considered applying them to a planetary surface. Number 1. What did the researchers have to say? To do so, the researchers built a computer model of what may be occurring on Jupiter using a set of equations known as the shallow water equations and ran simulations. Chung Lee, principal author and 51 Pegasi B postdoctoral researcher at UC Berkeley, explains, "We wanted to explore the combination of parameters that makes these cyclones stable," says the researcher. However, the scientists eventually discovered that if the storms were encircled by a ring of winds that spun in the opposite direction from the spinning storms, an anticyclonic ring, a Jupiter-like stable geometric arrangement of storms, would develop. Storms reject each other rather than merging due to the existence of anticyclonic rings. Other planets provide a much wider range of behaviors than what you see on Earth, he adds. So you study the weather on other planets in order to stress test your theories. If you enjoyed this video, make sure to like, comment, and subscribe. It helps us grow and make more videos that our followers love to stay updated on all things outer space. See you next time!